In today's video, we will show experiments demonstrating how UPSs behave under short circuits, how to improve uptime by using UPSs together with RPCM Smart PDUs, and much more.
Hi, my name is Evgeny Laptev. I'm the systems architect at RCN Tech. Today I'm going to tell you how to organize a reliable and manageable power supply and distribution for remote facilities that have only one source of power by using RPCM Smart Power Distribution Units, or briefly RPCM Smart PDUs. Here is the misconception that we hear a lot. People say, why would we need an automatic transfer switching or ATS at the remote facility where electric power is fed from only one power source like external mains? Customers install uninterruptible power supplies or UPS at such facilities to ensure reliability of power supply in the event of temporary loss of the external mains feed. These UPS solve a simple task: prevention of power loss of equipment in case of loss of mains by switching to provision of power supply from batteries in order to ensure continuity of systems and business processes. Typical geographically distributed remote facilities mostly use inexpensive UPS with power capacity in range of 1 to 3 kilowatts. Smart features are usually not expected as long as the primary task being solved is switching to batteries should something happen. But what's going to happen if the UPS itself fails? What's the plan in case a short circuit on one of the consumers kills the UPS control plane, which leads to shutdown of all equipment? What if you need to perform maintenance of the UPS, for example change batteries, and the UPS design doesn't allow to do it without switching the UPS off? What if the UPS enters fail-safe mode due to high inrush currents during equipment startup after a blackout? And in general, how to monitor and manage power supply remotely if your inexpensive UPS can't do it? In order to solve all these tasks and issues at the same time, we suggest to add RPCM Smart PDU to your UPS-backed power supply setup. RPCM has two inputs, one of which, the primary, can be fed from your UPS, and the secondary, the backup one, can be powered directly from mains. If your UPS happens to fail for some reason, or you need to turn it off to perform maintenance, RPCM will detect loss of power from the UPS and will automatically transfer the load to the backup input, switching equipment to external mains. What's the best here is that the RPCM does it seamlessly without equipment ever noticing the power outage and going into restart. You can also protect your UPS from high inrush currents and possible related UPS protective shutdowns with RPCM's Smart Start functionality, which turns outlets on one by one with a default 1-second delay between them. These delays, by the way, can be tuned in order to start your infrastructure in correct order and with correct intervals, which can reduce the necessity to manually intervene to start facility after a power blackout. You will also always understand actual power consumption of every power device and will be able to identify the most power-hungry consumers and usage patterns. Knowing this information, you can better predict how long the UPS will work from batteries and maybe even optimize power consumption by redistributing or reconfiguring the most energy-consuming equipment. Most inexpensive UPS fail and die when a short circuit happens on one of the power-consuming devices, which leads to a shutdown of the UPS and all equipment behind it. Many manufacturers do not cover such failure cases by warranties. Those few models of UPS that can survive short circuits enter protective shutdown mode when the short circuit condition persists, hence turning off all powered equipment. We have found few such models. I have one of them here on the table. This is Delta UPS RT1K that was kindly provided for our experiments by our great distribution partner, the company named Tempesto. We love to show live demonstrations of what happens during different problem conditions. Now we're going to simulate a short circuit of one of the consumers powered by this UPS and see what's going to happen to the other consumers and the UPS itself. This UPS has one input fed from external mains. Here's what we're going to use on the load side: two light bulbs, network switch that will simulate an IT consumer workload, as well as a short circuit simulation device. So let's simulate the short circuit. What are we seeing here? All consumers have instantly lost power because the UPS has entered the protection mode. Good news is that this particular UPS model has not failed or died, but in order to get it back to work again and restore power supply to equipment, somebody has to be at the facility or spend time to reach it and turn it back on manually. That's what I'm going to do after removing the short circuit condition. Note that many other UPS models in this scenario will just fail and die, and you would have to replace them to make things work again. Now let's add the RPCM with развесистая ива or branchy willow serial name to this configuration. How do we feed power here? We have a single input feed from external mains. It is connected through a selective circuit breaker. In our setup we use ABB S751DR. We have the UPS input connected to this breaker, and the UPS output supplies power to the RPCM's primary input. RPCM's backup input is connected directly to the same circuit breaker. This time all the load is connected to the RPCM's outlets. As in the previous example, the load is two light bulbs, the network switch, and the short circuit simulation device. I'm simulating a short circuit. What are we seeing? Once the short circuit has appeared, the UPS has switched into protection mode for a short time. RPCM, having detected loss of voltage on the primary input, has activated its automatic transfer switching functionality, and all load has been switched to the RPCM's backup input, external mains. Right after switching to the backup input, the RPCM has isolated the short circuit on its fourth outlet. At the same time, the UPS has self-recovered, because the overload was there only for a short time. The RPCM, having seen the recovery of the primary input fed from the UPS, after waiting for a configurable stabilization delay, in this particular configuration it was set to 5 seconds, has switched the load back to the primary input. As you can see, all this time, all other load powered from RPCM's outlets was working without any interruptions. Especially for those of you who could have been worried by seeing slight blinking of the light bulbs during ATS switching and short circuit isolation, we've been demonstrating pings that were running through the network switch that was powered from one of the RPCM's outlets, and those pings did not interrupt. So the RPCM's automatic transfer switching and short circuit isolation works out without interrupting the operation of IT and telecom equipment. What can you do if UPS models that you use cannot survive short circuits happening on outputs? In that case, there are two options when using that UPS together with the RPCM. You can provide power from external mains as the primary input, switching to the UPS only when external mains goes down. This will allow you to significantly reduce the risk of the UPS failure due to a short circuit on the load side. Or you can use the UPS as the primary input, accepting the fact that the UPS will fail and die should a short circuit happen. In this case, you will get increased safety in mind, knowing that in case a short circuit happens and the UPS fails and dies, the RPCM will use its ATS functionality to switch load to the backup input, external mains. Short circuit will be isolated at the RPCM's outlet level, and what's most important is that your other equipment will continue working without interruptions. Finally, let's consider the worst case, when a short circuit happens when we work from batteries because external mains is down. I'm switching off external mains. Backup input power disappears. The UPS switches to batteries. Let's simulate the short circuit. In this case, due to the fact that a low power capacity UPS does not have enough power to sustain current level required to detect and isolate a short circuit, the UPS enters protection mode and all load turns off. If we haven't had RPCM in this situation, it would be exactly as I've shown you in the first example, when despite recovery of power supply from external mains, visit to the facility and manual intervention would have been required to start up the equipment. In our case, because we are using RPCM, as soon as power from external mains recovers, RPCM turns on from its backup input, external mains. The short circuit gets isolated at the problem outlet during the turning on process, and all the rest of the load turns on and starts to work in anticipation of visit of an engineer to identify the reason of the short circuit and to manually switch on the UPS. Well, let's see how it works. As you can see, thanks to the use of RPCM Smart PDU plus UPS together in a bundle, you manage to ensure maximum reliability of your facilities with equipment. And you can always remotely turn off, turn on, reset power to any of your outlets should one of the consumers hang. Inexpensive UPS can't do this. As a result, by using a bundle of UPS together with RPCM Smart PDU, you get a completely remotely manageable and resilient power infrastructure. You can save on some UPS costs as well, because many functions that cost extra money with UPS can now be done with RPCM Smart PDU. I hope you enjoyed this video. Do not postpone improving the reliability of your infrastructure. Order your RPCMs today. Thank you.